Okay, so I'm going to make a video explaining recursive equations for sequences. This, remember that recursive equations are not a different type of sequence, they're just a different way to write the equation. So what I have here is to get the next term, so t of n plus 1, that's the term after the one I'm on. To get the next term, I take the one I'm on, the term I'm on, and I subtract 9. And then the second part, a recursive equation always gives you where to start. So this says t of 1, or the first term, is 20. So I know that it goes 20 first, and then to get the next term, I subtract 9. So 20 minus 9 is 11. 11 minus 9 is 2. 2 minus 9 is negative 7, etc. Okay? And then this particular problem doesn't tell you to write the equation, the explicit equation, but I'll show you that. First of all, I know it's arithmetic because it's adding or subtracting. Now, officially, arithmetic is only for adding, but I can write subtraction in terms of addition, which would be adding a negative 9. So adding negative 9 to 20, I get 11. Adding negative 9 to 11, I get 2, etc. So the explicit formula, when it's arithmetic, is like y equals mx plus b, but it's t of n instead of y equals m, where that's the common difference, or we call it the growth, n plus b, which is the zero term. Now the zero term is not part of the sequence. So I start all of these with t of n equals, and then the growth, or what we call slope in linear equations, is how it's growing or changing. So it's losing 9, so that goes next, times n, which is the term number. This is term number 1, this is term number 2, this is term number 3, this is term number 4. And then I need the zero term. I don't have the zero term in the sequence, but I can go back one. If it's subtracting 9 every time, I can add 9 to get the zero term, which is 29. So this right here is the zero term, and this right here is the growth, or in sequences we call it the common difference, how it's changing. So then this one over here, it's the same thing, still recursive, but another way to notate sequences with a sub n plus 1. This is subscript, where this is just all on the same line. This is like an exponent, but it's down below. So this still says to get the next term, I take the term I'm on and multiply it by 1/3. And it says that the term I'm on, or term 1, 729. Now they could give me term 5. They could say a sub 5 is, and tell me a number, and then I have to work backwards to go back in the sequence, or forwards to keep going forward. But in this case, 729, and then I'm going to multiply it by 1/3. Well, multiplying by 1/3 is the same as dividing by 3, which is a lot easier. Especially on a calculator, because multiplying by 1/3, that's a repeating decimal, so it's hard to type in. So if I divide by 3, I get 243. Divide by 3 again, I get 81. Divide by 3 again, I get 27, etc. So this is telling me what to do, and this is telling me where to start. So if you look at your notes, you always get the how equation, like what to do or how to do it, and then you always get the where to start. For all recursives, you have to have 2 equations. Okay? So on that one, we've got this sequence, and then if I need to write the explicit formula, and this is geometric because it's multiplying by 1/3 every time. Instead of adding the same thing, it's multiplying. And then this one, I'm not going to use t of n's because I see that it's with the a, so I'm going to do a sub n. You could use t of n's, but usually you try to keep them the same. If it's with the a's, you're going to write your answer in a's. The explicit equation is a sub n equals, and then for this one, it's the 0 term times the multiplier to the nth power, where n is the term number. So the 0 term, I have to go backwards. I have to do 729 times 3 to get the term that would go before this. And remember, the 0 term is not part of the sequence, but I need it for the equation. And then times the multiplier, when it's 1/3, I actually write it with parentheses because the whole thing is raised to the nth power. The n has to be on the whole thing 1/3, not just on the 1. So that's why I put it in parentheses. If it was not a fraction, I wouldn't necessarily need parentheses. I hope that helps.